All right. So the nth root test just says you need a series that has all positive terms. So if your series doesn't have all positive terms, then you just have to take the absolute value of it like we've been doing. You can look at the limit as n approaches infinity of the nth root, that's why they call it the nth root test, of the nth term of your series and get some limit. If that limit is less than 1, you could be guaranteed that the series converges, and it also converges absolutely because you might have had to take the absolute value of it to get the positive terms. If the series has a limit of L being greater than 1, then the series is divergent, and if it's 1, it could be any of those things. It could be divergent, could be conditionally convergent, it could be absolutely convergent. It's inconclusive. So very similar to some of the other tests we've been doing, right? That if it's less than 1, it converges. If it's greater than 1, it's divergent. And if that limit equals 1, then it's unclear. We're not going to go and do the proof of this. If you want to find the proof of this, I'm sure you can do a search online and find it. It's not super complicated. So that's the basic idea of the nth root test. We're just going to do a couple problems using it, and you'll see that oftentimes what the series might look like when you want to use the nth root test is you'll have something like n to the n, or a bunch of things that are within it being raised to the power of n will often be good problems to use the nth root test on. So here we're looking at the sum from n equals 1 to infinity of n to the n over 2 to the 2 plus n. And first off, for all values of n, 1 or greater, is this series positive? Yes, wonderful. So we don't need to take the absolute value of this. If we wanted to, we could, but we don't need to. So what we will then do is we will just look at the limit as n approaches infinity of n to the n over 2 to the 2 plus n, and we'll take the nth root of that. And taking an nth root of it is like raising it to a power of 1 over n, right? The nth root of x is the same as x to the 1 over n. And so oftentimes it might be a little easier to look at it like this, with the 1 over n as a power. And what happens to a fraction when you raise it to a power? You have to apply that power to both the numerator and the denominator, right? And so what is n to the n to the 1 over n? Should just be not 1, it's n to the n to the 1 over n. Yeah, it should just be n, right? And what about 2 to the 2 plus n being raised to the 1 over n power? If I'm going to apply that 1 over n, it should be multiplied to both the 2 and the n there. So what does that power become? It becomes 2 to the 2 over n plus 1. And what happens as n goes towards infinity? Our numerator should be infinity, right? And our denominator, 2 to the 2 over infinity would be, that'd be 0, right? Plus the 1, so that just becomes infinity over 2, which is infinite, which tells us that this series is divergent. Easy enough? Yes, fun, very simple, very straightforward, hopefully. All right, let's take a look at this one. Notice that everything in here is being raised to the power of n, which makes this a very good candidate for us to use the nth root test. So first off, are all of the terms in here positive for all values of n? N equals 1 is, n equals 2 is, any even power or even value of n is, but any odd power of, or any odd value of n greater than 1, so like n equals 3 is going to give us 6 minus 27, right? It's going to be negative over a positive cube. It's going to be negative. So we'll say these are not all positive. So what do we need to do this time? We need to use the absolute value. So we're going to look at the limit as n approaches infinity of, and we'll just say the absolute value of 2n minus n cubed over 8n cubed plus 1 to the nth power, and we'll raise all of that to the 1 over n. And very conveniently, what happens with this? The n and the 1 over n as powers will cancel each other out, right? And so we just end up with the limit as n approaches infinity of the absolute value of 2n minus n cubed over 8n cubed plus 1. And what does that equal? That should be an easy one. Since this is just a rational function that we're taking the absolute value of, the rational function has the same degree in the numerator and the denominator. And so what do? You take the leading coefficients and divide them, and what do you get as your limit? The absolute value of negative 1/8, or just 1/8. And you should be able to tell me that 1/8 is less than 1, and therefore this converges. And we could also indicate it doesn't just converge, it converges absolutely. The absolute value of this series converges, and this series itself converges. Easy enough? Yes. Let's see. No, actually, sorry. No, you would never get conditional convergence for this using the nth root test, Nick. Only if L equal to 1, then you could find out that it might conditionally converge, and that, but you wouldn't be guaranteed about that. You'd have to go do other tests. All right, let's do one more. Should be easy. Do you guys want to do this one on your own? Or no? Should be pretty quick. All right, yeah, go for it. Go do this one on your own. I'll give you like a minute, and then we'll talk about it. Ready, go. All right, so first off, you looked at it and you said this does not have all positive terms, right? Not all positive. And so you said, let's look at then the limit as n approaches infinity of the absolute value of negative 5 to the n over n to the 1 over n. And that just gave you the limit as n approaches infinity of negative 5 to the n to the 1 over n is just negative 5. And our denominator becomes n to the 1 over n. And as n goes towards infinity, we've proven this limit once before, but what does that limit come out to be as n goes towards infinity? N to the 1 over n as n goes towards infinity is 1. So this just becomes absolute value negative 5 over 1, which is what? 5. 5 is greater than 1, and therefore this is divergent. Good or no? Cool. Excellent. All right, that is it for the nth root test. So now we will switch over and start looking at a few pre-response series questions. So here is the first one that we're going to look at. Can you guys see that one? Yeah. All right. So what we're going to do is I'm going to give you guys 15 minutes here to take a look at this one and see if you can work your way through A, B, C, and D. And then we'll go through them, talk about what the scoring guidelines were, all that fun stuff, and see how it goes. So everybody good? Everybody clear on what we're going to do? Yeah. All right. You have 15 minutes. I'll try to give you a warning when you got like maybe 5 minutes left. No, Nick, I had not posted these ones that we're going to do today in Google Drive. I'm only going to do a couple of them, but I'll put them up in the next like minute or so as soon as I have you guys start working. So I'll give you 15 minutes and I'll put them up right now. Ready, go. So for the first part of it, it gives you the series for e to the x, which is nice of them. Then they give you some function f of x that they say is e to the x minus 1 squared minus 1 over x minus 1 squared. Cool. Give you a value for f of 1, and then have you write the first 4 non-zero terms in the general term for something unrelated to everything they just wrote up there, e to the x minus 1 squared around x equals 1. So in order to write out e to the x minus 1 squared, we just have to take our series for e to the x, and what do we replace the x's with? Should replace them all with x minus 1 squared. So the first term of e to the x was 1. If I replace all the x's in 1 with something, I still just get 1, right? Second term, I should be replacing the x with x minus 1 squared. So it should be 1 plus x minus 1 squared. And then we should get plus x minus 1 squared over 2, or x minus 1 to the 4th over 2. And then the next one should be x minus 1 to the 6th over 6. And what does your general term look like? Should look like x minus 1 to the 2nd to the nth, or to the 2n, and then divided by n factorial. Is that what you guys got for part A? Hopefully. Cool. So this was 1 point. Give myself a little more room so we can do part B down here. This was 1 point, and this was 1 point. And so 2 points for part A. For part B, then we're going to use our series that we just wrote from part A to write the first 4 non-zero terms and the general term for f of x. So what do we need to do to our series for e to the x minus 1 squared to turn it into e to the x minus 1 squared minus 1 over x minus 1 squared. We need to first off subtract by 1, right? And then we need to divide it all by x minus 1 squared. So what do we end up with then for our first term? Should still end up with a 1, right? Because if I take my first term and subtract 1, I get 0, and divide by x minus 1 squared, that's still 0. But our first non-zero term should be from x minus 1 squared. And if we take that and divide it by the x minus 1 squared, we should end up with a 1. So if we need to answer your question there, a non-zero term just means a term that doesn't end up being 0. So if I take my first term 1, subtract the 1 from it, I get 0, divide it by the x minus 1 squared, that term is 0, so we just ignore that term when it says non-zero terms. Okay, so then why don't I subtract 1 from the x minus 1 squared before dividing it by itself? Okay, so the minus 1 is this entire series of e to the x minus 1 squared minus 1. So I mean, that just effectively boom, slashes off that minus 1 forever, and that takes care of that minus 1. Right, exactly. Not every term, it's this series, right? This is a series that we've written out here. We subtract the 1 from it, that gets rid of that minus 1. Cool. So the next term is our x minus 1 squared. If we divide that by x minus 1 squared, as I was saying, we end up with just the 1, right? This one, if we divide x minus 1 to the 4th by x minus 1 squared, we should get x minus 1 squared over 2. This one, we should get x minus 1 to the 4th over 6, right? And then the next one, which would have been x minus 1 to the 8th over what would have been 24, should now become x minus 1 to the 6th over 24. And so on. And now, what does our general term look like? The numerator is still x minus 1 to the 2n, but now what is our denominator? So this was term 1, this was term this is 2 factorial, right? This is 3 factorial. This is 4 factorial. If this is our 0th term, this one should have been 0 factorial, this one should have been 1, this one should have been 2, this one should have been 3. So it should be n plus 1 factorial, exactly. And so that's our general term. And this one, let's see, same point breakdown. First for non-zero terms was 1 point, and this one was also 1 point. So parts A and B was a total of 4 points. Any other questions on A or B before we move on to C? Okay, sorry, I have to go back. How I went from the terms from, so from the terms from A to B, first thing I did was I took my entire series from A, I subtracted the 1, so this 1 disappears. Then I just took each term by term, and divided it by the x minus 1 squared. So x minus 1 squared divided by the x minus 1 squared gives me 1. X minus 1 to the 4th over 2 divided by x minus 1 squared is x minus 1 squared over 2. X minus 1 to the 6th, when I divide it by the x minus 1 squared, gives me x minus 1 to the 4th, the 6 stays, and so on with each term. Does that make sense, Shayla? Yeah. Okay. All right, so for part C, it's asking us to use the ratio test to find the interval of convergence for the series that we just found. And so the first thing that we need to do is think about this series. For all values of x, are the terms always positive? For this series, are the terms always positive for x minus 1 to the 2n over n plus 1 factorial? For all values of x, they should be, yeah. Right? Either positive or 0, right? Because we're raising this to the 2n power. So we don't necessarily need to put it inside of absolute values. On their scoring guide, they did, but there's no reason per se to do that. So you should be looking at the limit as n approaches infinity. And the ratio test says the n plus first term, right? So that's x minus 1. It was to the 2n, so that'd be 2 times n plus 1. And what do we have? We had n plus 1 factorial, right, in our denominator? So that should become n plus 2 factorial. And we're going to divide that by the nth term itself. So we'll multiply by the reciprocal of the nth term, which will be n plus 1 factorial over x minus 1 to the. Everybody good with that? Okay. And so then x minus 1 to the 2n plus 2 over x minus 1 to the 2n should give us an x minus 1 squared. And n plus 1 factorial over n plus 2 factorial should make this over n plus 2. And what is that limit? X minus 1 squared is just some constant. So we have a constant over n plus 2 as n goes towards infinity, which should be. What should that be? Should be 0. And if the limit for your ratio test comes out to be 0, what does that tell you? It should tell you that the radius of convergence is infinity, and that the interval of convergence, which I think is what it actually asked for, is negative infinity to infinity. And again, that's what it specifically asked for, right? Was the interval, yeah. And so let's see how they broke this one down. They gave you 1 point if you correctly set up the ratio. And like I said, they had it all inside absolute value, but that's unnecessary for this particular problem. You got 1 point for getting 0 as the limit, and then you got 1 point for having your interval of convergence being negative infinity to infinity. Good or no? All right, let's take a look at part D. Part D says use the Taylor series for f, so this thing that we got here, to determine whether the graph of f has any points of inflection. So this is not really a series question per se. We're looking for points of inflection of a function, which means we need to take a look at the second derivative. So we're looking for f double prime. And if I take f double prime of my first term of 1, that's going to be 0, right? If I take it of my next term, I'm going to get 2 times x minus 1 over 2. And when I take the derivative of that, I should get what? Just 1. So my second derivative starts out as 1. And then for my next one, should be 4 over 6 times x minus 1 to the third. So 2/3 x minus 1 to the third. And then when I do that again, it should become what? It should become 3 times x minus 1 to the second. No, not 3. 2 times x minus 1 to the second. Everybody agree with that? And what is the, you don't have to write out any more of those if you don't want to. What is the derivative of the nth term going to come out to be? Or the second derivative, sorry. We're going to end up with 2n times x minus 1 to the 2n minus 1 is our first derivative, right? So I'm going to write this as 2n times x minus 1 to the 2n minus 1. That's the first derivative. And then the second derivative of it, I did plus 1 factorial down here. Second derivative becomes what? 2n times 2n minus 1 times x minus 1 to the 2n minus 2 over n plus 1 factorial. You all agree with that? That would be your second derivative of the nth term of that series. Okay. So we've got positive values for n, right? So 2n is always positive. And I believe our series started at n equals, what did our series start at? Oh. They didn't specify, but we're looking at n equals 1 because we're looking at n equals 2 because we've taken the second derivative. At the least, we're looking at n equals 2 because we started at n equals 0 and took 2 derivatives. And so if n is 2, this is also going to be positive. And then x minus 1 to the even power is always going to be positive, and n plus 1 factorial is always going to be positive. And so we know that for all x, this is greater than or equal to 0, because if x was 1, then it would be equal to 0. And if there are no sign changes of your second derivative, then that means no points of inflection. Good or no? And you'd get 1 point for finding the second derivative term, and 1 point for saying no points of inflection, with a reason. Any questions on that, or is that good? Okay, mediocre. If the series were to alternate, you're saying if we put in like -1 to the n plus 1 or something in there, or -1 to the n, Nick?
Well, I was just saying, like, if the second derivative, if it came to be where they weren't all positive, like for all x.
Yeah, then we could say that there could be points of inflection, yeah.
But would we need to like find them or just determine if there are any?
So, I mean, for this particular question, you wouldn't be able to. If it was alternating, you wouldn't be able to find what they were. And I think if you read into the wording of the question, it specifically says just determine whether it has any. It doesn't actually say to find them.
Okay. So
if it doesn't say to find them, don't bother trying to find them. It's probably because you can't find them. But we can at least indicate whether there are or are not any. And in this case, there are not any.
Okay.
Yep. Any other questions on that? Anybody? How many of you got all 9 of those points? So our goal will be, we want to get at least 6 out of 9 on every free response. Preferably better than that, but at least 6 out of 9. All right. So here is the next one we're going to do. We're not going to have time to do more than just this one. And in fact, we really won't have time to go over this one, but I'd like you to spend the next 15 minutes now before class is over working through this one. And then you'll see that there's one more in the PDF that's in the blank notes. So go find this one also and work on that one sometime before tomorrow. And those will be the first 2 things that we go over tomorrow, but I'm going to put a 15-minute timer on for you guys to work on this one right now. So please don't just leave. Please stay and do this for the next 15 minutes. All right, ready, go.